Our first speaker this afternoon is Sheida Rashidi, joining us from our car. They'll take questions. She'll take questions at the end, so please reserve your questions until she concludes her speech. And so at this time, let's give a warm welcome to Sheida.
Hi, everyone. Thank you for being here. So today we're going to talk about accessibility in AI. And as an example project, I'm going to walk you through a sign language recognizer. So a little bit about me. Right now, I'm an associate at Our Car. You might have seen their cars around the cities. You rent cars by hour. It's a very nice nonprofit that gives the gift of mobility in this country to so many carless people like me. And I graduated from Macalester College with a degree in computer science and psychology. I studied abroad in the UK. Before that, I went to a high school in Hong Kong. And from never being out of my country, I'm originally from Iran. Never being out of Iran before, I suddenly got dropped on the campus with 67 nationalities. So that has shaped me a lot as a person I am today. I feel like so many people tell me, oh wow, doing computer science and psychology is very unique. And I always liked tech. I was always passionate about tech, but I knew I'm not a person who wants to just sit and code and not have any human aspect in it. And that's how I moved a lot towards human-computer interaction and accessible technology. I put photos of my friends and travels down there because they shape a big part of my identity and a big part of my interest. Because when you meet so many people with diverse needs and diverse backgrounds, you cannot just see the world the same and just think about everything in the context of yourself. So, why accessibility matters? I think something that bothers me is that we talk about accessibility a lot as it's a feature, but it should not be a feature. It should be the bare minimum. It is one of the basic necessities that we should have in each project. It just puts you in a weird loophole because there are not that many people with different disabilities or different abilities in the tech space. Therefore, there's not technologies being developed for these people. Therefore, they never again get a chance to be in this space. So this just cycle of like not representing others is happening. And it's our responsibility to make sure we could cover this gap. It prevents so much biases. It lets, as I said, makes people be able to participate in such spaces. It encourages new solutions. If we look at the world through diverse needs, we come up with new solutions that maybe we couldn't think of in the context of ourselves. Some examples that we could talk about is unbalanced data sets. Many facial recognition systems have 35% chance to recognize the face of women of color wrong because they've been tried mostly on white male subjects. Or in language models, so many times it has happened that they have correlated the word of programmer to a man and homemaker woman. And I remember 2 years ago, I was at a conference for Google, and they were just developing a technology that helps you search images by skin tone and hair texture. And then I realized why I can't find any images for curly wavy hair at that day, because I think if you have that hair, you understand that. It's impossible. And now it's finally getting better. And it was so interesting for me to see that happening. Even though I had that problem, I couldn't think of it because it felt like the solution was never presented. So you're just used to that cycle of not having that option. So let's walk through an example project of an accessible project. How did this project start? Once I was going to a disability center in my school, and as I got in, the person at the reception stood up and started signing to me, and I was so confused for a second. And then the interpreter started talking, and it took me a moment to click that. And I felt really bad because I was totally acting confused for a good moment. And I was like, well, this person's jobs really, really depends on this interpreter being there. That's not cool. Like, why there's not something right now that we could use so for her to independently be able to communicate with every other student on campus? So that's how the idea started of creating a sign language recognizer system. According to WHO, 466 million people live with disabling hearing loss. And so yeah, I wanted to make something that bridges this gap. What technologies was used? My photos are not loading, but So we use TensorFlow, which is an open library that is used for mostly machine learning models. It was developed by Google. And on top of TensorFlow, Keras runs, which is another library that really is another API that helps with training machine learning models, images, and it has a very user-friendly system, and it's very good for beginner or advanced level. And TensorFlow and Keras just make a perfect big powerhouse for training a system that needs a recognition of images because we're training it on sign language. Jupyter Notebook, if you worked anything AI, you're familiar with it. It's an open source, just online tool that you could share code, type code. It's very efficient for AI and machine learning because you could run each chunk of code separately. And the highlight of this project is using MediaPipe library. I got introduced to MediaPipe again at another conference through Google, and basically it just cuts down a lot of work. So if you have any personal projects, MediaPipe is a great tool to start with that. At the time we started this, it has 33 key points on face, on as a body, more than 468 key points on the face, so it could recognize smiles, frowning, very little details in your face, it could recognize it. And it had 21 landmark for each hand. So overall, it's a very, very great tool for training machine learning models on movement, objects, and human body. It cuts down a lot of time. It does a lot of work for you, so you could focus on the other details. Neural networks is one of the most used things when it comes to especially image training. So what is neural networks? It really sounds like the neural nodes in your brain, and it's kind of what it does, exactly what it sounds like. So each neural network has this nodes that you see. And these nodes have a relationship, and they help to predict and read patterns. So many of machine learning models that need prediction and understanding are running on neural networks. There are two types that are used in this project, is a convolutional neural network, or CNNs, and recurrent neural networks, or RNNs. So what's the difference between those? CNNs are great for image recognition. They have a grid-like remembering, so images, you could make a grid out of it. So that's why we use majority CNNs in this project. That's just a way better tool than RNN for recognizing images. However, RNNs are still great tools for sequences, so like sentences, numbers, anything that it's a sequence of things is great at predicting that. And the project has used both because we wanted to both read and be trained on an image and also be able to write it out and spell it out. Extracting key points, I briefly explained it, but the neural network, as we said, it has some nodes. So I said MediaPipes has those key nodes. So when you look at the hand in this image, each one point on the hand is a keynote. And when you're training your machine learning model, it's not being trained on your whole hand. When it's looking at this finger going up and down, it's counting keynote 8, 7, 6, 5, is looking at those dots. Where are those dots going? And that is how it learns the model. When you train that finger movement 20 times, 30 times, 100 times to that model, it starts remembering, okay, red, when it moves to this point, and at the same time, if this other red moves to this point, it probably means that. So the model is all depending on this little key points that need to be. Think of it that in elementary school, you had a homework that you had to go find every one important word in a sentence. That is how key point extraction works. Look through everything and find that one thing that is repeated and what is the pattern in that. It focuses on what matters. Like if you were in the keynote speaking, the Chihuahua photos, what makes a Chihuahua? You have to focus on the ears. Ears could be a key point. That facial structure, different parts of it could be a key point. Then we have a long short-term memory model. So many normal traditional RNNs suffer from the fading gradient problem. What is a fading gradient problem? Is as you keep training and adding more to your data, the older data tends to be not to forgotten, but the distance becomes larger and larger. You keep adding a stack in front of a stack in front of a stack in front of a stack. So I always use the example of my grandmother when she was telling me a story at night. She would start with the story of Heidi, and by the end of it, we're totally in another subplot. And I'm like, what happened to Heidi? And she's like, who? We lost it completely because we moved on. We're in another place. And that's how sometimes it happens with the traditional models. But with long short-term memory, think of it as an attentive reader. Think of it as the person in front of your class who's taking notes and writing down every important part of the lecture. So at the end of the lecture, she has all these notes to look back on and remember, oh, the professor said this, here is it, I have it down. So that's why we use a lot of, use of long short-term memory is more convenient. And there is like the structure, the architecture is 3 gates. For get gates, it just ignores the irrelevant problem. So for example, if you have the keynotes and you're seeing this finger is happening and you see a chihuahua here barking, you're gonna ignore the chihuahua. You're gonna look at the finger, that's the important part. The input gate decides that the keynote is important. I'm gonna input that. And the output gate looks at the model, looks at what was happening, what we learned, and gives an output. So 4 steps of making a sign language, accessible sign language recognizer. Collecting data. I had to sit down in front of that camera and say beautiful, beautiful, beautiful 30, 40 times because I didn't have enough storage. 30, 40 times was not enough. Ideally, you need that model to be at least like trained at least 100 times. Where are you gonna get that people? Who's gonna do it? Am I gonna do it? Very big concern. So each video was about like 5 seconds. And yeah, we just had to repeat it, and feed the model each separate gesture. Recognition at the same time, I will show you a demo in a second, and interprets text from that recognition. So, it's not loading. Sorry, I'm gonna check, I think it's an internet issue here. Did not see that through. Let me make my promises. Okay, hopefully, here. So this is how training worked. I'm just doing the gesture 1 time, 2 times. I'm on number 22 here if you notice. And then output. I think we're not having audio, but it's basically reading out the data. So this is like, hello, my name is like Sheida. I came up with my name like this, and your name is beautiful. So here it is. We have a sign language recognizer. Yay. Many would consider this like project done. We're done. We have an AI recognizer. That's amazing. And they might just put a little dashboard for you that has your image and has the audio underneath it. Amazing. But is it? It's not a gesture recognizer. It's a sign language recognizer. At the beginning, we had an issue that people are like, okay, we're going to feed this alphabet. Okay, what am I going to do with alphabet? I'm going to spell hi every time someone wants to say hi. No, you need to learn the language for it. You need to learn what movement you do for that saying hi. Training, who is training it? Am I qualified to? I don't know if that was correct. Like, I don't know if that was correct. Sorry, I tend to walk. I don't know if that was correct. I knew one student that worked in a disability office that knew how to sign. So am I in a place to be like, I am making this product? Have I talked to that person enough? Is the technology good enough? This was struggling to run on my laptop. And there are some assistive speech devices. They are out there in the market, and they are, you know what, expensive. So okay, we create this technology and put a $3,000 price point on it. What's the point of that? Which comes to the inclusivity. Again, was the system fair represented? I don't think it was. Was it a success project? Yes. Did I get an A? Yes. But I don't think it marked a good product that needs to be out there. And that's why I spent a year doing research on it. Because that just reading out loud on my laptop, I don't think that is enough. There wasn't only one person that we talked to that had an idea of sign language. Also, how is user privacy? We're putting a camera on a device and recording people. How do we protect that data? What are those privacy concerns that come in? And ensuring equal access. Again, I did a project that this expensive device was not meeting the user requirements. We had to do add-ons to the tablet that they use every day to speak with. And all they wanted was to talk about SpongeBob, and they couldn't. So we had to go in and design an element that they could personalize and talk about SpongeBob. And that was amazing for them. They were so happy. Imagine you cannot talk about what you like because the very expensive device you paid for cannot do it. So what could we do about this? It's a long game. AI and data science is relatively new. Right now at lunch, I was talking with some people, and I'm like, how could we start working more on data laws? What is a major for? Do you know any school that has a course on data and laws and privacy? We really don't have much on it right now. So we need to make sure that when we are training our data, we are having representation. If we are working with people with disabilities, we have them in the process. They are not just test subjects. They need to be there while you're designing this in every step. It's not that here, I made this. Do you like it? No. Make them actively involved. Because imagine as women, we have men that have designed menstrual cycle apps for us. And there's so many things wrong with that, and there's not a woman included in that. So now imagine you have a disability and someone else is deciding for you what is good for you. I was working at a neurotech company that we made brain implants. Not the Elon Musk one, don't judge me. We worked on disabilities. And we talked to people with spinal cord injuries. And we were talking about what assistive techs they work with. And again, it's crazy that these people are paying so much, and it's like, the device is not recognizing my speech. If I'm having an episode, it's not recognizing it. Or it falls. What do I do when it falls and I cannot move? And it's just baffling to me that we are looking at the technology so profit-based. We are not focusing on users enough. Transparency is really important. As I just said a moment ago, every time I say I worked on brain implants, everyone is like, ooh, scary. So transparency of what are we doing with this data? Where is this data going? How is it being trained? Is very important to be talked about. And again, diversity, diversity, diversity. I feel like we talk about diversity enough, but we don't see it enough in the teams. And just because you have one woman, 2 black women, 1 ginger, this AI-generated photo, you see, it's not showing it. This is what AI thinks of diversity right now. There is a rainbow, so we cover the LGBT, we put 2 black women and a ginger, and that's it. Diversity in a photo. That's not enough. Well, thank you for listening to me so far. And if there's any question, I would love to hear it.
We'll get you a microphone.
Do you plan on doing any additional development on your product, or actually turning it into a product at some point?
So we were working on it. I was working with my professor part-time till my visa allowed. And there, we worked on it of making it faster and less time, but it never got to development. I couldn't work there anymore, and their budget runs out. But I know there are apps out there. Actually, like a friend of mine is working on a sign language recognizing app that I think is deployed right now.
I can see how it could be difficult to cover every edge case possible. So for example, if somebody needs to do modified sign language because they're missing a finger or 2 fingers, whatever it may be, I can see where situations like that would be very difficult in this case to cover. Is there a point where you have to draw a line on accessibility, or how would you try to approach every single edge case like that?
That's fair. I think in your very first point, you should try to start with as much as information you could in the beginning. So, as you said, yes, some person might not have some fingers. It's a bit more rare for that to happen. But we make sure we have actually sign language speakers on the team. We make sure they are involved in the training. So our base model would at least be somehow to what we could accessible. And then it's important to be open to change. So as I was showing an example in the AAC devices, which is assistive speech device for people who cannot speak themselves, the device was not customizable. And that was a big problem because, okay, it's covering the basic needs, but you need to leave room for expansion. You need to leave room for customization.
So we do have one question from our virtual attendees, and someone was just wondering how many signs can your app recognize, or how many signs did you train it to recognize?
Let me remember. This model was not fully on the, absolutely not everything, but for demos, it was at least like, I think 10 sentences that I was making sure that is recognizable, like it's been trained on that. But I had system limitations. But at the end, after the research period, I don't remember exactly, but it was maybe at least 100 words minimum. And then you could put that in sentences and make sentences with them.
Awesome. Thank you so much, Sheida, for this fantastic presentation. Let's give her another round of applause.